Another way to solve a system of linear equations is by the addition method. So let's look at the steps of solving a linear system by addition. Step number 1. If necessary, rewrite both equations in the form of ax plus by equals to c. Number 2. If necessary, multiply either equation or both equations by appropriate non-zero numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. Step number 3. Add the equations in step 2. The sum is an equation in one variable. Step number 4. Solve the equation in one variable. Step number 5. Back substitute the value obtained in step 4 into either of the given equations and solve for the other variable. And last, step number 6. Check the solution in both of the original equations. So let's use the rules that we just talked about in solving this systems by the addition method. Step number 1 told us to write our equation in the form of ax plus by equals to c. And I have that. I have my x term plus my y term equals to my constant. And they're both in that form. So step number 2 said we need to multiply through either the first line or the second line or possibly both so that we can eliminate either the x or the y. In order to eliminate a variable, let me show you an example. If I want to eliminate the x's and I have 9x, I need negative 9x so that when I add these, they cross each other out and eliminate a variable. So when I look at this equation, I see that I have positive 9 and I have positive 3. Is there a number that I can multiply times 3 to give me negative 9? Yes, there is. So let's multiply the first line through by negative 3. So let's do that. Negative 3 times 3x is negative 9x. Negative 3 times 2y is negative 6y equals to negative 3 times 48. I believe that's going to give us negative 144. Okay? Now, since the second line already has positive 9, I'm just going to write down the second line just as it is. Now I'm going to draw my line. Now I'm ready to add. Add the two lines. Well, when you add, the x's cancel. When I add here, negative 6y and negative 8y, that's negative 14y, equals to, when I add negative 144 and negative 24, I get negative 168. Now my next step will be to solve for y. Let's divide both sides by negative 14. So if you use your calculator, 168 divided by 114, excuse me, 168 divided by 14 gives me 12. So just as solving by the substitution method, once you find one of the letters, you just need to take that value of y, which is 12, and plug it back into either one of the original problems. So if I plug it back into the original problem, 3x plus 2y equals to 48. I'm going to plug in 12 in for y. So I have 3x plus 2 times 12 equals to 48. That's 3x plus 24 equals to 48. Let's solve for x. Subtract 24 from both sides. I end up with 3x equals to 24. Last, let's divide both sides by 3. So x equals to 8. So, the point of intersection for these two linear equations is x is 8 and y is 12. So we solved this equation by the addition method. Now let's look at another one using the addition method. solve a system by the addition method. Remember, our first step is to put them in the form of ax plus by equals to c. We have to have the two linear equations in the same order. The x's have to be lined up, the y's, the equal signs, the constants, so that when we add, we can eliminate one of those variables. So let's put both of them in this form. Here I have 2x equals to 7y minus 17. So let's subtract 7y from both sides. And when I do that, I end up with 2x minus 7y equals to the 7y's cancel minus 17. So I can't subtract an x from a y, so I just have to write those side by side. Now taking the second equation, 5y equals to 17 minus 3x. Again, let's get it in the form of ax plus by equals to c. So let's add 3x to both sides. When you add 3x to both sides, the 3x's cancel on the right-hand side. So I end up with 3x plus 5y equals to 17. Both the 5y and the 3x are positive. So now we have these two linear equations in the same form. They're both in the form of ax plus by equals to c. So I'm going to rewrite those. Now, I've got to decide, do I want to eliminate the x's or do I want to eliminate the y's? It doesn't matter. You can choose either one of these. Now, if I choose to eliminate the x's, I have 2x and I have 3x. Now, there's not a number that I can multiply 2 by to get 3. So therefore, I know when I multiply these together, I get 6. So if I multiply the first line through by 3 and the second line through by negative 2, then I would have positive 6x, negative 6x, and then they would cancel. So that's what I'm looking for. I'm looking to multiply either one of the lines or both of the lines so that I can end up with the product being the same number but opposite signs. Therefore, they would cancel. So to get rid of the x's, I'm going to multiply the first line through by positive 3, the second line through by negative 2. And you have to multiply the entire line by that number. So let's multiply each one through the first line by 3. 3 times 2x would give me 6x. 3 times negative 7 is negative 21y equals to 3 times the negative 17 would be negative 51. Now let's multiply the second line through by 2. Negative 2 times 3x is negative 6x. Negative 2 times positive 5 is negative 10y equals 2. And negative 2 times 17 gives me negative 34. So now let's add these two lines together. The 6x's cancel. Negative 21 and negative 10, that's negative 31y equals 2. When you add negative 51 and negative 38, I get, negative 34, I get 85 negative. Okay, so when I divide both of those, or when I divide both sides by negative 31, 85 divided by 31, I end up with a decimal. 85 over 31, so I'm just going to leave that in reduced, simplified fraction form. Okay, I don't think there's a number that'll go into both of those, and therefore I'm just going to leave it in that fraction form. Okay, next, what I'll need to do is I will need to substitute this fraction back into one of the original problems. So let's do that. Taking either one of the original problems, I have 2x equals to 7y minus 17. So I'm going to substitute my y back in to find my x. So I have 2x equals to 7 times 85 over 31 minus 17. Now keep in mind 7 is over 1. So let's begin solving for x. I have 2x equals 2. Let's multiply 7 times 85. So doing that on my calculator, 7 times 85 gives me 595. And this is 1 times 31 is 31. minus 17. I'm going to see if I could reduce that fraction as far as into a whole number, but I can't. So let's continue working here. 17 is over 1. In order to add and subtract fractions, I have to get a common denominator. So we need to convert both of these to 31. So we already have the first fraction in terms of 31, so let's bring down the numerator. Now, how many times does 1 divide into 31? Well, it would go 31, and then what is 31 times 17? I end up with 527. So dealing quite a bit with fractions on this problem, but still, let's continue working with this. If I subtract here, writing down my common denominator, 31, 595 minus 527 gives me 68. So I have 2x equals 68 over 31. All right? So then the way that I could eliminate the 2 in front of x is multiply both sides by the reciprocal. If I multiply both sides by the reciprocal, that's the same as dividing both sides by 2. See, on the left side, 2's over 1, the 2's would cancel. Over on the right side, if I multiply straight across, I get 68 over 62. 31 times 2 is going to give me 62. Now, I know that I can reduce both of those by 2. Let's see if we can reduce both of those by a number larger than 2. And I don't think we can. So let's just divide 68 by 2. Reducing that would give me 34. And 62 divided by 2 would give me 31. So that is my 64 divided by 31 is my x value. So if I was to write this as an ordered pair, my x is 34 over 31, and my y is 85 over 31. So yes, you can have quite a bit of fractions in these problems sometimes. You just have to work through them. To multiply fractions, like we did at this step, you do multiply straight across. And then when we had to subtract fractions, I had to get a common denominator of 31. So this problem definitely goes back and has us to work through using our fraction skills. So to add and subtract fractions, you have to get a common denominator. To multiply fractions, you can always multiply straight across. And on this last step here, rather than dividing both sides by 2, I just went ahead and multiplied both sides by the reciprocal, to make x have a 1 in front of it. So it ends up x was equal to 34 over 31. For my final answer, 34 over 31, and y was 85 over 31.